Good afternoon, dear students of SIT Engineering College. I am Devendra Tiwari, Assistant Professor in Electrical and Electronics Department, presenting here my YouTube video lecture on the topic Kirchhoff's Law, that is KCL and KVL. So we'll understand here its concept, its introduction, and how we will apply this KCL and KVL. So we will start this topic. So first of all, introduction of Kirchhoff's law. In 1845, a German physicist Gustav Kirchhoff developed a pair or set of rules or laws which deals with the conservation of current energy within electrical circuits. These two rules are commonly known as Kirchhoff's circuit laws. So Kirchhoff's law dealing with the current flowing around a closed circuit called KCL, while the other law that deals with the voltage source present in a closed circuit known as KVL. First of all, Kirchhoff's first law, that is current law. So Kirchhoff's current law or KCL states that total current or charge entering a junction or node is exactly equal to the charge leaving the node, as it has no other place to go except to leave, as no charge is lost within the node. In other words, we can say algebraic sum of all the currents entering and leaving a node must be equal to 0. That means I exiting plus I and entering should be equal to 0. This idea by Kirchhoff is commonly known as conservation of charge. So this is a small circuit diagram which will make you understand more clearly is Kirchhoff's current law. See the node given to us and 5 currents are here. Some are entering and some are leaving. Currents entering a node equals the current leaving the node. This is all about Kirchhoff's current law. So with this diagram, we can clearly see I1, I2, and I3 are the incoming currents, while this I4, I4, I5 are the leaving currents. So three currents entering I1, I2, I3 are positive in value, and two currents that is leaving I4, I4 are negative. So equation will be I1 plus I2 plus I3 minus I4 minus I5 should be equals to 0. We can say I1 plus I2 plus I3 equals to I4 plus I5. Now, Kirchhoff's second law, that is voltage law. Kirchhoff's voltage law or KVL states that at any closed loop network being driven by a voltage source, the total voltage around the loop is equal to the sum of all the voltage drops within the same loop, which is equal to the 0. In other words, we can say algebraic sum of all voltage sources and voltage drop within a closed loop must be equal to 0. Since the algebraic sum of the voltage drop equal the algebraic sum of voltage sources, this idea by Kirchhoff is known as conservation of energy. So here simple circuit diagram is given to us. Resistances are placed here and we have marked the directions in which we are traveling in the circuit. So as per KVL, the sum of all the voltage drop around the loop is equal to 0. So here A to B there is resistance R and A to D also, C to D also, and D to A. So VAB plus VBC plus VCD plus VDA should be equals to 0. Starting at any point in the loop, continue in the same direction. This we have to keep in mind. Nothing, noting the direction of all the voltage drop, either positive or negative. So maybe there will be battery also given here, but not battery in any interest inside it. So we have to take out the sign conventions also. So continuing either positive or negative and returning back to the same starting point. It is important to maintain the same direction. This is the most important condition. Either clockwise or anti-clockwise, or the final voltage sum will not be equal to 0. We can use Kirchhoff's voltage law when analyzing series circuit. So this is all about Kirchhoff's current law and Kirchhoff's voltage law. Hope you will understand this topic and we will meet in the next video. Thank you very much.